Last subtopic 8.5, diffraction by a single slit. Diffraction is the bending of light wave as they travel around obstacle or pass through a narrow slit. Assumption for this diffraction is the first one, the diffraction slit size is small relative to the wavelength of light, which is A less than lambda. Assumption 2, screen is far away and rays are parallel. As you can see here, the amount of bending depends on the relative size of the wavelength of light to the size of the slit. If the slit is much longer than light wavelength, the bending will be almost unnoticeable. However, the slit A less than lambda, the amount of bending is considerable and easily seen with naked eyes. Diagram for diffraction by a single slit. Consider monochromatic light of wavelength lambda passing through a narrow slit of width A and shine on distant screen. According to Huygens principle, each point on the wavefront at the slit act as secondary sources emitting new wavelets that radiate towards the screen. Wavelet from one portion of the slit interfere with light from another portion and generates diffraction patterns on the screen. For theta equal to 0 degree, all wave interfere constructively creates a bright central fringe on the screen directly opposite to the slit. And then the wavelets emitted by Huygens sources in the slit can also interfere destructively and create a dark fringe on screen. This diagram shows a single slit diffraction pattern. The brightness of the fringe is related to the light intensity. At the center is midpoint of central bright fringe. We have first minima, second minima, and third minima, which is dark fringe. Between each pair of dark fringes, there is a bright fringe due constructive interference. Most of the light intensity is concentrated in the broad central bright fringe, and the higher order bright fringes are much less intense than the central fringe as the graph indicates. This diagram shows how to get the formula of diffraction by a single slit. We have at the central, which is central maximum, and the dark one is first minimum, and bright first maximum, and dark is second minimum. The last one is second maximum for bright. Okay, a dark fringe, which is minima, is obtained at angle where A sine theta n is equal to n lambda. And A stands for width of the single slit, and then theta n is angle for the nth minimum and measured from the central axis, and then lambda is wavelength of the monochromatic light used, and then n is the order number, which is n equal to 1, 2, 3, and so on. Formula for diffraction by a single slit: for distance of n order dark fringe minima to the center of the central bright fringe, which is yn at the diagram there, and then yn is equal to n lambda d over a, and distance from n order bright fringe maxima to the center of the central bright fringe, yn is equal to n plus half lambda d over a. Width of the central bright, as you can see at the diagram there, W, yellow one, W is equal to 2y1, which is 2 lambda d over A, where capital D is distance between single slit and screen, A is width of the single slit, lambda is wavelength, and N is order number. Last subtopic, diffraction grating. Multiple slit or multiple slit. Diffraction grating is a device with a large number of equally spaced parallel slits, as shown in figure. This diffraction grating can be made by rolling very fine parallel lines on glass or metal by a very precise machine. The spaces between the lines serve as the slit, and slit separation is given by D equal to 1 over N, number of line. D is equal to, for example, number of line here, 600 lines per millimeter. Convert to meter, D is equal to 1.67 times 10 power of negative 6 meter. Slit separation, also known as grating spacing. Formation of diffraction grating pattern can be explained when monochromatic light is incident on the diffraction grating, each slit acts as secondary source and emitting large number of secondary wavelet. These diffracted secondary wavelet interfere with one another. As the light fall on the distant screen, it forms central bright fringe n equal to 0 and higher order bright fringe, which is n equal to 1, 2, 3 and so on either side. These bright fringe are due to the constructive interference and also called as maxima. Theta 90 degree from the diagram generally is the angle associated with n order maxima is given by d sin theta equal to n lambda. Highest order that can be observed is limited by the fact that theta cannot exceed 90 degree, which is sin theta less than 1.0. When sin theta less than 1 and lambda over d less than 1, then n less than d over lambda, where n here is order number, d is slit separation or grating spacing, which is d equal to 1 over n. Lambda is wavelength of the incident light. Theta is angle associated with n order maxima. Application for compact disc. The first one, the surface of a compact disc has many tiny spiral groove, track or rulings, with the adjacent groove having a separation on the order of 1 micrometer. This groove acts similarly to a series of tiny slits diffraction grating. When compact disc is viewed in white light, the light reflecting from the region between this closely spaced groove interferes constructively in certain direction, forming colored lens. Different colors have different wavelength. Different colors will be reinforced at different angles and a color spectrum is produced. This picture shows the application of the compact disc experiment. Exercise 8.3. Monochromatic light of wavelength 689 nanometer falls on a slit. If the angle between first bright fringes on either side of the central maximum is 38 degree, calculate the slit width. Okay, given here, wavelength and first bright fringe at the central maximum 38 degree. Calculate slit width. Okay, how to calculate these questions? As you can see, either side of central bright maximum is 38. Theta there 38 is actually means theta 1 is equal to 38 divided by 2, which is 19 degree. And the question mention that first bright fringe means that n equal to 1, and bright fringe we use this equation A sin theta 1 n plus half lambda, and we calculate, we get A 3.17 micrometer. Question 2, light wavelength 633 nanometer from a distant source is incident on a single slit 0.750 millimeter. And the resulting diffraction pattern is observed on a screen 3.5 meter away. Determine the distance between two dark fringes at the side of the central bright fringe. Okay, list the formation given first. Given lambda 633 nanometer, and then what else? A here is 0.750 times 10 power of 3 meter. Okay, then D 3.50 YN yang kita nak cari. Okay, ini kita draw lah dulu. Kita lukis sikit. Kita lukis. Okay, dekat central tu. Okay, kita lukis first minima situ. Okay, first minimum. Lepas tu dia nak between two dark fringes, means that daripada central ke second minimum lah. Okay, YN kat sini, N kita adalah 2 lah. Yang merah tu adalah width dekat central bright. Itu adalah width. Okay, A adalah slit tu. From slit A. Dan dia kata dark fringe. Okay, dark fringe N sama dengan 2. Jadi kita guna equation Y2 is equal to apa equation Y2? Okay, N lambda D over A. Okay, substitute nilai, kita akan dapat Y2 adalah sama dengan 5.91 mm. Exercise 8.4. Okay, let's move on to another exercise, which is regarding diffraction grating. The first order maximum line of 589 nanometer light falling on a diffraction grating is observed at an angle of 15.5 degree. Then determine the slit separation on the grating for A and B, the angle of diffraction for third order maximum line. Okey, terus sekali kita tulis apa yang diberilah, information given. Okay, given here, okay, lambda is equal to 589 nanometer. Okay, convert to meter. And then given kat situ angle 15.5 degree. A disuruh cari slit separation which is D. And then B disuruh cari theta 3, which is when N is equal to third order maximum, which is N equal to 3. Okay, kita buat yang A dulu. Yang A, sebab dia nak apa tu? Separation, slit separation D. Kita guna D sin theta N lambda. Kenapa kita guna D sin theta N lambda? Sebab dia kata first order maximum kat situ. First order maximum, lepas tu observe. Okey, jadi N sama dengan 1 lah. Okey, bahagi dengan sin theta. N sama dengan 1. Lupa nak tulis kat information given tu. Jadi lambda, tulis dulu lah, N sama dengan 1. Dan lambda kat situ adalah 569. Darab 10 kuasa negatif 9. Kisah ni balik. Okay. Lepas tu bagi dengan sin. Theta pun given kat situ 15.5 degree. Dan theta D yang kita dapat ni adalah sama dengan 2.2 mikrometer. Okey, untuk yang B pula. Soalan B dia suruh cari angle. Samalah kita guna rumus D sama dengan sin theta n lambda. D kita dah ada. So daripada N1 ni kan. Okey, D kita guna 2.2. 10 kuasa negatif 6. Sin theta yang kita nak cari. N kita 3. Okey. N kita 3, lambda kita sama. Kat source yang sama, 569 nak 10 kuasa negatif 9. Lepas tu, dapatlah theta. Okey, theta. Tekan kalkulator. Cuba salin dulu. Theta kita akan dapat 53.4 degree. Itu saja. Terima kasih. Okay, next topic is quantization of light. Topik 9.